Hi everyone, this video is to introduce you to section 5.5, which is inequalities having absolute values in them. So we've done stuff with absolute value before. We've seen how to graph absolute value functions. We've done inequalities. We're kind of putting a couple of things together here. So to introduce you to this, we're going to start very simple. Absolute value of x is equal to 3. Well, if you think about it this way, there are only two numbers for which the absolute value of x can be 3. Absolute value means make everything inside positive. So if x was 3, the absolute value of x is 3. And if x was negative 3, the absolute value is 3. So just to show you, this is what I'm saying. Both of these are true. So that means for this statement, x could be equal to positive or negative 3. There are two values. Well, now let's turn this into an inequality. Suppose now that I said the absolute value of x must be less than or equal to 3. Well, what that means is the distance from 0, remember when we talked way back last semester about absolute value being distance from 0, the distance from 0 is less than or equal to 3. So what that looks like on a number line, if this is negative 3, and this is 0, and this is 3, I have to be less than 3 away from 0. Well, that would be this part, but then at 3 I must stop. And then 3 the other way would be here. So what we actually see, this looks like an AND graph. Suddenly, absolute value of x less than or equal to 3 is x must be less than or equal to 3, and x must be greater than or equal to negative 3. So if you notice, it's less than or equal to 3, just like it looks like, but then x is also greater than or equal to, the sign changes, the negative. We're going to use the same concept to graph stuff that isn't just x in the middle. So now, what if I have something that looks like this? The absolute value of x minus 4 has to be less than 12. We're going to use the same concept here. If you guys remember when we did word problems, this meant the distance from the distance from 4 must be less than or equal to, sorry, not less than or equal to, just less than 12. So if you remember, whenever you see x minus, that means the distance from. So you can kind of get an intuitive sense of what's going on. But if we want to just jump to our inequalities, let's look at the last example. We did x is less than or equal to 3, and x is greater than or equal to, flip the sign, and then make that negative. We're going to do the same thing here. X minus 4 is less than 12, and x minus 4, flip the sign, is greater than negative 12. So now we're going to solve like usual. X is less than 16, and x is greater than negative 8. And so we can actually see this. The distance from 4 is less than 12. Well, 12 away from 4 is 16, or negative 8. And so we must be less than 12 from 4. So 4 is going to be our center value. And I'm going to jump actually by 4s here. So 4, 8, 12, 16, 0, negative 4, negative 8. I must be greater than negative 8 and less than 16. So we get this in-between value where 4 is the center and 12 away from that gets the either end. Now, the last type of problem that you're going to see is one that's actually not possible. And I'll give you that kind of ahead of time. If I now say the absolute value of x has to be less than -5, what this means is the distance of x from 0 has to be less than -5. Well, it's not possible to have a negative distance. And so if you see absolute value smaller than a negative, and it has to be less than or equal to, the answer is right away no solution. But if you want to see that algebraically, we can use the same concept. Here's the work. X is less than -5, and x is greater than, so we flip the sign and change the sign of this, +5. Well, how can I be on a graph smaller than -5, but bigger than 5? What's going on here, -5, less than -5 is to the left, greater than 5 to the right. Remember that and means the intersection. And if we look at the graph, they never intersect. These two are separate. And so because there is no intersection, there is no solution. And so your graph would actually look like an empty number line. This would not be here, and this would not be here. So it all ties together. You can either logically see that, or you can go through the algebra and figure out that it's no solution. If you are done and you feel like you understand this, then your homework, I know I told you guys number 1 through 7, but I actually want you to have a reduced homework. So on what page was it? Page 312, I only want you to do number 1 through 3. That's it, 3 problems. If you feel like you need a couple more examples, I'm going to go through a couple more examples in the rest of this video, but again, if you feel like you have it and you want to try the problems, go ahead and do that. If you're staying with me for a couple more examples, I actually want to do now 2x minus 5 in the absolute value is less than or equal to 7. So again, to solve this, we're going to take what's inside the absolute value, 2x minus 5, and just copy this exactly as it looks, is less than or equal to 7. Now, less than or equal to, we're always going to use an and. This will be important when you see what we'll do tomorrow. And then again, take what's inside the absolute value, 2x minus 5. Instead of writing less than or equal to, we already did that, flip the sign and change this 7 to a -7. And that's because of what the absolute value does with negatives. So we have 2 cases here. Now we're going to solve like usual. 2x is less than or equal to 12, and 2x is greater than or equal to, add 5, we get -2. Divide both sides by 2, we get x is less than or equal to 6. And don't forget we're dividing by a positive, so this is actually x is greater than -1. Now that you have this, which if you want you can write it like this, x is between -1 and 6, then if this is -2, -1, 0, 1, 3, close circle, and then connect the middle. And that's it. Another example, if I now have 2x minus 5, so that same insert is less than -5, well, we can't be less than a negative. So if you see this setup smaller than a negative, where this is absolute value, this is always going to be positive. So if you think about it, can a positive number be less than -5? That's not possible. So no solution. And there's no number line. You could put numbers on it, but there's no shading. All right, see you all tomorrow.